Good morning everyone. Today we are going to do the product rule for differentiation. So when is the product rule used? When the graph is of the form y equals to fx times gx, we will use the product rule. Do note that fx and gx are two different expressions of x that cannot be simplified when multiplied together. If fx and gx can be multiplied together, then you shouldn't be using the product rule. Let's start with the product rule cheer. Product rule cheer. It goes like that. Product rule. Copy first, differentiate second, plus copy second, differentiate first. Let's repeat the product rule cheer together. Product rule. Copy first, differentiate second, plus copy second, differentiate first. In this rule, if you noticed, I'll call the expression in front as first and the expression behind as second. And that's why the cheer goes like this. Copy first, differentiate second, plus copy second, differentiate first. Do repeat this product rule several times before continuing with the slides. I believe you have cheer at least twice. Let's carry on with two examples using the product rule cheer. Example 1. Find f prime x for each of the following functions of x. So you are given two questions over here in example 1. We will proceed to solve part A using the product rule cheer. For part A, we first let fx be equals to x squared plus 2 times x minus 3. We identify the first expression as fx and the second expression behind as gx. So this first expression we call it first, and the one behind we call it second. So to derive f prime x, which is the first derivative of fx with respect to x, we will actually do the product rule cheer. Copy first, differentiate second, plus copy second, differentiate first. Do note that the order is important. Follow the order of the cheer strictly. Copy first, differentiate second, plus copy second, differentiate first. So with this, we copy x squared plus 2. When we differentiate x minus 3, we obtain 1. Plus, we copy x minus 3. When we differentiate x squared, we will use the power rule. Power comes down, power minus 1, in which you get 2x, and when you differentiate plus 2, you will get 0. So you get two terms over here. This is the first term, adding on to a second term. Notice these two terms has no common factors. So what we do is we expand all the brackets. X squared plus x times 2x will get 3x squared. Over here we have minus 6x, and if we collate the constant term, we have plus 2 times 1, which is plus 2. So the net answer after differentiating fx will be 3x squared minus 6x plus 2. Now we'll proceed to part B. Before explaining part B, I would like to revise a factorization technique which you have learned in your lower secondary. Suppose you are given two terms, a power half adding to a power minus half. And I would like you to factorize this expression. How would you go about factorizing? Would you take out half? Or would you take out the a with power minus half? Those of you who think that we should take out power minus half is correct. We usually take out the a with a smaller power, and in this case minus half is smaller than half, so we'll take out the term a power minus half. So that's what I did. I take out a power minus half, and after that open bracket. Now what should this term be if the first term here doesn't have power minus half? What we do is that we do a reverse thinking. We ask ourselves, a power what times a power minus half will give you a power half. So instead of working forward, we try to multiply these two terms and get a power half. Now notice that I have to add the two powers together. So if I were to add the two powers together, this power here will have to be 1. A power 1 times a power minus half will actually give you a power half. So after factorizing a power minus half from the first term, you get a power 1. Then we add. Now this term has been carried out as a common factor, so this term here becomes 1. So this is the result of factorizing the terms a half plus a power minus half. Please understand this concept clearly before proceeding to part B of the example. Now let's go through part B. We first let fx be the given expression. Again, the expression in front, we call it first, and the expression behind, we call it second. Then we do our cheer for f prime x. Copy first, differentiate second, plus copy second, differentiate first. Again, note that the order is important, so follow the order of the cheer strictly. Copy first, differentiate second, plus copy second, differentiate first. Now, we copy this expression x squared minus 2, and then when we differentiate the second expression, we notice that there's a bracket and a power. So we use chain rule. Power comes down, power minus 1, differentiate inside. Differentiate 3x will give us 3, differentiate minus 4 will give us 0. Plus, copy the second expression, and we differentiate x squared minus 2. So differentiate x squared, we use power rule. Power comes down, power minus 1. And when we differentiate minus 2, we get 0. So the net result for differentiating x squared minus 2 is 2x. We notice that after differentiation, you will basically only get two terms. The first term in front, adding to a second term behind. what are the common factors in these two terms? Notice that 3x minus 4 power minus half and 3x minus 4 half are common factors. So we attempt to take out the common factors. We also notice that there's a fraction here that cannot be cancelled out with 3. Half could not be cancelled out with 3. So we also take out half as a common factor. 3x minus 4 power minus half. So let's take a look at the first term. The first term, after taking out half and 3x minus 4 power minus half, I'm left with 3 times x squared minus 2. Adding. Now how about this? If you take out power minus half, what will happen? Recall our previous example on a power minus half adding on to a power half. If I take out common factor a power minus half, I'm going to get 1 here, and for this term I'm going to get a power 1. Let us work backwards, okay? A power 1 times a power minus half, and you will get a power half. Now here there isn't the number half, but I brought up the number half. So to cancel out this half, I must have a 2. So the remaining term is 2x, which is left inside the square brackets. Now to check this factorization, which is the most important step, it is important that you work backwards. You take this term times the first term to ensure that you get this first term. Adding on to you take the front part times the back part over here. You ensure that you will get the second term behind, just to check. So with this, we have completed our factorization. So this half, I'm going to put it as 1 over 2. And this 3x minus 4 power minus half, I'm going to bring to a denominator, which becomes square root 3x minus 4. Now how about this square bracket? If you took out the right common factors, it should end up having a very nice expression over the numerator. Let's check. 3 times x squared plus 4x times 3x. 4x times 3x will give you 12x squared. Adding on to 3x squared, that will give you 15x squared. And here you have 4x times minus 4, which will give you minus 16x. And let's check the constant term. You have a minus 3 times 2, which is minus 6. So with this, we finish the whole example for part B. Thank you for your kind attention.